All right. So, hello and welcome everyone. So, we are live right now. Okay. So, welcome back. I know it's been a long time. So, welcome back after a long time on this particular channel of Tutee Learning. Yes, so we are back again with our previous discussion on circles. So, let us start with discussing about the circles topic where we have ended in our last class, right? So, there has been a lot of things going on in the couple of weeks. So now what we have decided that we are going to start with our one shot JEE revision series, right? So you must have all got your JEE mains dates, right? So for your JEE mains examination, we are going to start with one shot revision session, okay? So one shot revision session which is going to start tomorrow, okay? So one shot for your JEE mains first attempt, right? So your one shot session is going to be like a 1 hour lecture, 1 hour lecture on revision. Okay, so this lecture is going to be a revision of the previous topics or whatever topics you have studied, and then we'll have some 30 minutes to 40 minutes of questions. Okay, so there will be, this is going to be the sequence or order of the portion that we're going to discuss, right? So in the first 1 hour lecture, we're going to discuss about all the possible theories, all the possible short concepts and everything in detail, right? In detail, please make sure to have a basic understanding of the chapters one before we are starting the what's the one shot lectures, right? And after that 1 hour lecture, we're going to also have a 30 minutes of supplementary sessions, which is going to be consisting of only questions, right? So in this 30-minute session, we are going to have only question, right? So maybe what I can do is that I can split the videos in two parts, and we can have one part of the video for lecture, and the 30 minutes part or the second part would be for the question solving sessions. Okay, so in this question solving session, we are going to definitely discuss about the JEE mains previous year questions, along with the question that I feel that is very very important, especially for your upcoming paper, right? So all those questions I'm going to discuss in this particular one shot sessions. Okay, so please make sure to attend this very important lecture series, right? So this one shot is going to be a gold mine for all of you who are preparing for the upcoming JEE Mains examination. Okay, so if you are going to appear for the JEE Mains first attempt in January, then definitely this session is going to help you a lot. Okay, so please make sure to join us live on this particular channel itself. So with that due, please subscribe and hit the bell icon so that whenever we are live, you get a direct notification, right? And also the class timings would be in the morning 10 a.m. I'm not committing to it, but yeah, it's going to definitely in the morning 10 a.m. and maybe you can also have an evening sub classes of that like 2 p.m. Okay, 2 p.m. evening classes as well, right? So this is going to be the timing in general. However, along with that, if I feel that sometimes we have to be quick enough with the syllabus, so maybe then I can take a 9 p.m. class as well, right? So depending upon the flexibility of the timings, we can definitely have a classes over here, right? So this is all what we're going to do in our upcoming month, right? So in the month of December, you can basically be sure that we will be hitting on this revision session, and we're definitely going to finish up the entire syllabus of mathematics for your JEE Mains, right? So that is all, and with that particular thing, let's get started, right? So we have been discussing our circles. So I hope if you remember the last class, we were discussing about the concept of normals, tangents, and along with that we discussed about the concept of common tangent, right? We discussed that how many common tangents will be there to a given circle, and how to find out the length of the common tangent or the exterior tangent, like those all those questions we have discussed in our last class, right? So in today's class, we're going to start with our main idea that is going to be discussion of the angle between two intersecting circle, right? So we are going to start with our today's topic, that is angle between two intersecting circles. Okay, angle between two intersecting circles. So let us start to understand how do we calculate the angle, or how do we find out that what is the angle between two circles, okay, or two intersecting circles. All right. So this is what we will have. Now, right, so let us try to draw the situation and try to understand, right? So what I mean by two intersecting circles, so let us say I have one circle and another circle which is intersecting like this, right? So at this point of contact or at this point of intersection, let us call this point as P. What I will do is that I will draw two tangents, that is, let us call the first circle as S1 and let us call the second circle as S2. So I will draw two tangents at point P to the first circle, something like this, and I will also draw a tangent to the second circle, something like this, right? So let us call these tangents by some name. Now it is very obvious that the tangent may or may not pass through the center, right? So let us call the center as C2 over here and this center as C1, right? And let us name the tangents. Let us call this tangent as BB dash and let us call these tangents as A and A dash, right? So these are the tangents we will have. Now let us also join the center to center distance, right? This is CC1, which is the center to center distance, right? And along with that, this is my radius R1 and this is my radius R2. These are the radius R1 and R2. And we know that the tangent is perpendicular to the radius, right? So this is what we will have. Now let us call the equation of the first circle as S1 equal to 0 and the second circle equation as S2 equal to 0. This is what the formulation of the question looks like. Now, if I want to talk about that, what is the angle between the circles? It is basically defined as it is simply defined as the angle between the tangents, at the point of intersection. So this particular angle theta is defined as the angle of the circles, okay, or angle between the two intersecting circles, right? So this is how we actually calculate the angle of or angle between two intersecting circles, right? So let us try to jump into the mathematics part of it. So how we can estimate this theta from these known parameters like r1, r2 and c1, c2, right? So if I try to do that, so if I again come back with this triangle over here, so if I try to figure out from this triangle, so you can observe that there is a triangle pc1 c2, right? So this is a triangle over here PC1C2. So in this triangle PC1C2, what you can observe carefully is that in this triangle PC1C2, what you can observe is that this is my length of the radius R1 and this is the length of the radius R2, right? So these are the two lengths, and along with that, what you can also observe is that this particular angle is going to be theta, right? So this angle over here is going to be theta. Right. Now our main and sole purpose is basically to estimate this particular angle theta. Right. Now in order to estimate this angle theta in any arbitrary triangle, we will take the help of the cosine law. Okay. So cosine rule, which is basically being taught in a solution of triangles. So using the cosine rule, we can use it to estimate cosine of theta is basically going to be PC1 squared plus PC2 squared minus C1 C2 squared and whole divided by 2 times of PC1 multiplied with PC2, right? So this is how we can estimate the value of the cosine of theta, right? So if I apply this over here, what I can get is that I can get cosine of theta will be equals to r1 squared plus r2 squared minus the c1 c2 distance is whole square divided by 2 times of r1 r2, right? So this is what is going to the angle going to be looking like, right? So in order to find out this angle between two circle or two intersecting circle, this is how we calculate this value of theta, and this theta is going to represent that what is the angle between two circles, right? Is this part clear to all of you? Is this part clear to all of you? Do let me know in the live chat. Is this part clear? Are we all clear on this? Okay, so from here, what we can also note that it is very important to also realize that the main question that is basically being asked in circles is that we have to find the condition for orthogonality of circles, right? So the main condition over here comes that we have to find out the orthogonality condition. So what happens when two circles are orthogonal, right? Or orthogonality condition. So we will try to find out the orthogonality condition as, so we know that if the circles are orthogonal, that means the angle theta should be equals to plus or minus pi by 2, right? So if the angle theta is plus or minus pi by 2, then cosine of theta will be equal to 0. Then cosine of theta will be equal to 0. And in this case, I will have 0 will be equals to r1 square plus r2 square and minus this particular distance. Let us call this distance c1 c2 as d. So minus d square whole divided by 2 times of r1 r2 divided by 2 times of r1 into r2, right? So this is what I will have the condition, and from here I can easily estimate, and you can see that my r1 square plus r2 square should be equal to d square for the orthogonality condition, right? Now, if I say you that we know the equation of the circle in the format, let us say the circle equation of the first circle equation is given as x square plus y square plus 2 times of g1x plus 2 f1y plus 2 f1y plus c1 is equal to 0. And in a similar manner, if I write the equation of circle C2, that is x square plus y square plus 2 g2x plus 2 f2y plus C2 is equal to 0. If these are the two equations of the circles, then from here I can plug in the R1 and R2 values, because we know that the radius of circle is basically given as root under g square plus f square minus c, right? That is for the general circle, right? So similarly, if I apply that, what I will get is that I will get the condition that is 2g1 g2 plus 2 f1 f2 is equals to c1 plus c2. C1 plus C2, right? So this is the condition that we obtain for the orthogonality of circles. So if I give you generally the equation of the circle and I say that the circles intersect at a perpendicular angle or 90-degree angle, then the orthogonality condition says that this will hold true. So 2g1 g2 plus 2f1 f2 is equals to c plus c1 plus c2, right? So please take a note of this particular property, and we will try to use this in our solution of questions. Okay, is this part clear to all of you? Is this part clear? So let us try to solve one problem to understand, right? So try to solve this problem, okay? So try to solve this problem using this particular above property, okay? So please try to solve this problem. Please try to solve this problem. Please try to solve this problem and tell me the answer you're getting. So if you read the problem, it is said that a circle passes through the origin and has the center on the line y equals to x. Now if it is said that it cuts the circle, this particular circle, orthogonally, then you have to find out what will be the equation of the new circle. Alright, so let us try to see how we will solve this problem. Now as I said that the center of the circle lie on the line y equals x, right? The center of the circle lie on the line y equals to x. So it is very obvious that we can assume the center. So let the center of the circle be assumed as alpha comma alpha, right? Because it is lying on the line y equals x, so I can easily assume the center of this particular circle as alpha comma alpha, right? Now it is also said that this circle, so the center is alpha comma alpha, can also be estimated. So from here we can also estimate the equation of the circle, right? So if I try to write the equation of circle in terms of alpha, it is going to be minus 2 alpha x minus 2 alpha y plus some c equals to 0. That is going to be the unknown equation of the circle, right? Now Now from here we can find the orthogonality condition using, and this particular circle whose equation is given as x square plus y square minus 4x minus 6y plus 10 equals to 0. And so if we use the orthogonality condition, that was 2g1 g2 plus 2 f1 f2 is equal to c1 plus c2, right? So using this particular condition, so here my g1, let us call this g1 is equals to 2 and f1 will be equals to 3, and similarly from here g2 is equals to alpha and f2 is also equals to alpha, right? So if I do that, then we'll get this condition that is 2 times of alpha into 2, that is going to be 4 alpha plus 6 alpha, it should be equals to 10 plus some constant c, right? So this is how we will have the equation, right? Is it clear? All right, so from this condition we can estimate that. Now also it is said that very clearly that the circle also passes through origin. So whenever a circle passes through the origin, the constant value of that particular circle equation is equals to 0. So from here we can also get one condition, that from here we'll get the value of alpha as equals to 1. So from here we get the value of alpha equals to 1. Therefore the I think there should be one minus missing over here. Let me check. So yes, so this is, I think this is correct, right? I think it's pretty great, right, correct. So we have got the value of alpha as 1. So therefore from here the unknown equation of the circle will be x square plus y square minus x minus y is equals to 0. So that is the required equation of the circle. I hope this question is clear to all of you. I hope this question is clear to all of you. Please do let me know in the live chat, is this part clear or not? Is this part clear? Okay, so let us now move forward with our discussion on the next topic, that is going to be radical axis, right? So this radical axis concept is a very interesting concept in case of circles. Okay, so in case of circle, radical axis is one of the very crucial chord. So it is basically defined as the, so radical axis is defined as the locus of the point, which is or locus of the point which moves such that the length of the tangents drawn from it, right, drawn from it to the two circle, from that particular point to the two circles, should be equals. Okay, so that is the locus condition, that should be equal, right? So we should have the length of the tangent drawn from that particular point to the two circles should be equal, right? So if I have to assume the equation of circle, let us assume the equation of the two circle as x square plus y square plus gx plus fy plus c is equal to 0, and let us assume the other equation of the circle as s dash, and that is given as x square plus y square plus 2g1x plus 2 f1y plus c1 equals to 0. Now let us call that particular point P as some x1, y1 be a point such that if I draw a tangent to the two circles and the tangent is PA and PB, so that particular distance should be equal, right? So this is what my condition says, right? So if I try to do that and I try to find the locus of this point P, So if I try to do that, let me try to show it by a diagram. So let us say this is my circle 1 and let us say this is my circle 2, this C1, C2, and let us take a point P over here such that the tangents drawn from this point P to the two circles are equal in length, right? So this is how the locus will look like. So P is given as x1, y1, and this is, let us say, point A, and let us say this is point B. So we will have the condition that is Pan equals to Pb, right? So what you can see is that this is how the locus of this radical axis is going to look like. So it's basically a straight line, and that is also, you will be seeing that, right? So if I use this particular condition of the equality of the tangents, what we can get is that we have seen very clearly that the length of the tangent is simply given as square root of s1, right? That is what we have seen. So if I do that, so that will be equals to square root of x1 square plus y1 square plus 2gx1 plus 2f y1 plus c. That should be equals to square root of x1 square plus y1 square plus 2g1x1 plus 2f1y1 plus c1, right? This should be equal. So if I square and simplify on both the sides, so if I square and simplify both the side, I will get the condition that is 2 times of g minus g1 x1 plus 2 times of f minus f1 times y1 plus c minus c1, that should be equals to 0. This is the locus equation. Now we have already learned that the equation of locus for x1 y1 is given like this, which is nothing but the equation of the circle, right? And we have already seen that in locus, after we find for x1 y1 on the h comma k, we replace it with x comma y, right? So this is the locus equation. Now what you can observe is that the locus of this radical axis is a straight line. Okay, so this is a very interesting observation, that a point from where, if you draw a tangent, two tangents to a circle such that the tangent lengths are equal, then that particular locus is basically a straight line, and that is what we also call as radical axis. I hope this is clear to all of you. Is this part clear? Hi Saloni Raj, very nice way. I am a 11th grader, a dedicated JEE aspirant. Great Saloni Rai 0, right? Great. Is this clear to all of you? Saloni, it's better if you watch it from the first lectures, okay? Or if you have done till the previous lectures, then it is easy for you to understand these things, right? All right. Is this part clear to all of you? I hope this is clear. I hope this is clear to all of you. All right. So let us now move towards solving some problems, right? Now there are a lot of properties regarding the radical axis. However, I don't think they are very important, so I would restrain myself to basically not discuss about that. Now also, along with the radical axis, we also have a concept called as radical center, right? Or radical center, and that is a concept where, that is a simple concept where we have, let us say we have three circles. So for each pair of circle, we will have one of the radical axis, right? So let us say for circle S1, S2, we have a radical axis. Let us say this is my R1. For S1, S3, we have a radical axis. Let us say it is R3. For S2, S3, we have a radical axis. Let us say R2. So wherever these radical axes are meeting, this particular point O is called as the radical center. Okay, the simple concept. We will have multiple combination of question of like this, right? I hope this is clear to all of you. I hope this is clear. Okay. Now, along with that, we can also have questions where we will be asked to find out the common chord. Okay, the equation of the common chord, right? Now, this kind of question actually requires not a much of discussion. Rather, we can directly go on to solve question, right? So, depending on the question to question, this particular property will vary, right? So, let us say we have two circles with the center C1 and C2, and if we want to find out the common chord, which is like this, let us call this common chord as AB. So if I want to find out the equation of the common chord AB, then that will be easily found out by finding out these 2 points, right? Which is nothing but this. So let us say this x1, y1, and let us say this x2 and y2, right? So this x1, y1, if I try to solve the equation of circle by substituting for the value of y in x, and then we can solve this equation, then x1, y1, but x1, y2 will be the two roots of that quadratic equation that you are solving for, right? So just try to solve the equation of the two circles. Okay, so just try to solve the equation of two circles to get to this final answer, right? Now if you try to do that, you will see that the equation of the common chord will simply turn out to be s1 minus s2 equals to 0. Okay, so the equation of the common chord is simple as the equation of the radical axis, right? That is basically, let us say, g1 g2 into x plus 2 f1 f2 into y plus c1 minus c2 is equals to 0, right? This is my equation of the common chord. Okay, so this is my equation of the common chord, which is very similar to that of radical axis. Okay, so the equation is similar. So radical axis. Okay, so equation is similar to the radical axis. I hope this is clear to all of you. And once we get the point A and point B, we can also find out the length of the common chord, right? So this is all sort of variation that you will be finding out in the questions, right? So as we approach to the end of this particular portion, now our time has come to discuss about the final important topic, that is going to be the family of circles, right? So now we will discuss about the concept of family of circles, and we will try to include this in our next class discussion as well, right? So I'm basically going to introduce the basic concept of what is a family of circle, and then in the next class we're going to see all sort of variations that is possible in the concept of variation of circles, right? So the simple concept of a family of circles that we can have is that, let us say we have two circles, they're intersecting each other, and I want to form another circle or all sort of set of circles which is basically having the same point of intersection. Okay, let us say this point of intersection is A and B. So if I want to draw another circle, something like this, another sort of circle which is passing through point A and point B. So this particular circle, let us say this equation is given as s1 equal to 0 and s2 equal to 0. Now if I want to find out another circle or another such set of circles which is basically following the same property, that is basically they are the member of the same family, right? The simple property is that they are passing through the same point of intersection, that is point A and point B. So in order to find out this particular equation of circle, so this equation of circle can be given in terms of the family of circle, that is basically s1 plus lambda times of s2 is equals to 0, right? So this is the simplest form of the family of circles, okay, which is satisfying the sole condition, that is the circle is passing through the point of intersection of these two circles. Now in the similar manner, we can also have another variation, is that instead of finding out the point of intersection in terms of circle and circle, we can also have one circle and one straight line, where the line equation is given as L equals to 0 and the circle equation is given as S equals to 0. In this case also, by passing the point of intersection of this line and the circle, we can also draw another circle, and that equation of the circle will be similar to the previous one. Instead, we will have S plus lambda times of L equals to 0, right? So this is how the equation of the family of circle will look like in these following two cases, right? Now there can be further more variations of this family of circle equation, that what we're going to discuss in our next class, right? So in today's class, let us quickly go on to solve some problems. Hi nature lover, bhai NEET ke alag dekh. Hi Jitendra Kumar, nature lover, hi. Alright, NEET के लिए अलग देख site है क्या? Yes, for NEET platform we have basically our another channel. Okay, for NEET we have our another channel called as Tutee Learning NEET. Okay, so you can search that up. Alright, is this part clear to all of you? Is this concept clear to all of you? Let us go on solve some problems, right? So that it is easier for you to understand and grasp whatever we have studied so far. Right. So a very simple problem I would like to give you is basically to find out the common chord or the length of the common chord. Okay. So let us say we have this question over here. So this is the question that you have given, that let us say we have two circles which are intersecting. So and you have to find out the length of the common chord. Right. So in order to find out the length of the common chord, which is much simpler. What you can do is that you can use the properties of circles, right? Let us say this is my first circle, and let us say this is my second circle, right? So the common chord is passing like this, right? Now we know that the circle, the chord is basically perpendicular to the radius, right? So if I know this is my radius r1, so if I know this particular distance, the perpendicular distance from the equation of the chord, right? This perpendicular distance can be easily given out. So this C1 is basically, let us say, minus G1 comma minus F1, right? This is my circle center C1. So from C1 I can find out the perpendicular distance by finding out the equation of this common chord. So the equation of common chord can be taken as S1 minus S2 is equal to 0, right? This will give you the equation of the chord, and from this we can use the condition of perpendicular distance of a line and a point. We can find out this particular distance d, right? So this particular distance is basically like we have already studied, that is a, if the equation of the line comes as ax plus by plus c equals to 0, then it is a, let us call this, so our point is minus g1 minus b times of f1 plus of c, and take a mod of it, and then divided by square root of a square plus b square, a square plus b square. So this is the distance is going to look like, right? Now once we have calculated the distance, we can use this particular distance to calculate this particular length. Let us call this point as O. So we can calculate the BO length by using the Pythagoras theorem, that is going to be r1 square minus d square. So therefore the length of the common tangent is going to be 2 times of this BO distance. So length of the common chord is 2 times the BO. I hope this is clear to all of you. I hope this question is clear to all of you. Can you try it out and tell me the answer you're getting? Can you try to solve it out and tell me the correct answer? Anyone? Anyone with the answer yet? Alright, so if you solve it up, you'll see that the answer should come out something as, so the value of this AB distance, this value of this distance AB should come out something as 2 times of square root of 106 by 5 units. Right, so this is going to be the final answer to this particular problem of the length of the common chord. Is this part clear to all of you? So please take these things in mind so that when you solve questions of JEE Mains, you will be able to use this part, right? So these are very important, and especially if you look at the JEE Mains problems, these kinds of problems are very similar problems, okay? And you can expect to have this kinds of problem appearing in your paper as well, right? Alright, so I hope this particular discussion of our circles is clear to all of you. So in this particular class, let us conclude our discussion on circles, and maybe in the next class, when we're going to meet again tomorrow, we're going to complete our discussion on family of circles, right? So today we have introduced to the basic concept of family of circles, and in the next class we're going to see all sort of variation of family of circles, and with that we're going to solve some more problems into family of circles. And if we finish once family of circle is done, then I can comfortably say that we have already covered the entire chapter of circles, right? And the remaining part that is left is basically to practice some miscellaneous problems, right? So maybe in 2-3 lectures we will be, or maybe in 2 lectures we will be winding up with this particular topic of circles, and with that we're going to start with parabolas, right? I hope this particular discussion is clear to all of you, and with this I wish to conclude the session over here. Thank you, and I